It's me, Mr. Moran, lesson 49. Glad you're back. Haha, just kidding. Me, Mr. Moran, your math teacher. You're watching this lesson because either you want to review lesson 49 or you missed it for some reason, right? So go ahead, take a minute, pause it, try to do the do now, and we'll come back and talk about it. Or you want to just do it with me. Either way, pause or keep going. Here we go. He says, find each product or quotient, which we've covered in the last couple lessons, right? And we're going to write using exponents. So what's another way of writing x to the fifth times x to the second times x to the third? If you're multiplying by the same base, we multiply any coefficients. 1 times 1 times 1 is 1. And add the exponents, 5 plus 2 plus 3, which is x to the 10th. There we go. There is our simplified standard form. Number 2. This times this, all multiplication, we can follow our rules of multiplying or writing monomials in standard form. 5 times 3, 15. A to the third and a to the second, a to the fifth, b to the fourth, and another b. We'll have 5 b's multiplied together. 3, a little tricky. We have v to the fourth times v to the third. The rule is multiply, right? But now we have division, right? And the rule was divide any coefficients, which there are none, and then the numerator exponent minus the denominator exponent. So v to the negative second. Boom. And that was like for the homework last night. Last one, we have a little bit more, but we do have a coefficient. So 24 divided by 3 times x to the, well, we have x in the numerator and denominator. So numerator exponent minus denominator exponent. And there's y. 24 divided by 3 is 8. 5 minus 5 is 0. Y to the fifth is y to the fifth. There we go. Hopefully that went well for you. There are the answers. There's some of the work. Okay. So in our second part, our fourth lesson for chapter 6. Here we go. What we've kind of left out, and some of you have been asking questions about, is thinking about like, Mr. Man, 0 and negative exponents, right? How does that work? What does that even mean, right? So let's space, and this is what mathematicians did thousands of years ago or hundreds of years ago. 0 exponents made sense, but they had to make sense of like negative exponents and 0 exponents. So what we know to be true, 4 squared, another in exponent form, and expanded form 4 times 4, and standard form 16, right? And 4 to the first meaning 4 copies of 4. Okay. What we need to answer, and we kind of left up in a couple different places, is what does 4 to the 0 mean? Okay. So what do you think 4 to the 0 might be? It's always a great way just guessing, seeing what we think. In class, a lot of people think it could be 0, right? Maybe it is. 0 copies of 4. Some people say 4. And I say that's a great guess. We're just guessing, right? Some students say undefined, like it's not possible, right? We've seen undefined. So I'm going to leave it, maybe it's one of those, but I'm going to take you through some thinking, and I want you to maybe come to your own decision. Okay, now I'm going to show you some stuff. I want you to work your way through the problem to see if 0 or 4 or undefined or whatever you think it could be is correct. I'll even throw some students say the number 1 out there. Just so if you said that, then that's what you're thinking. Okay. Here we go. Amy and Max argued about what 2 squared divided by 2 squared is. Amy said 2 squared over 2 squared is 2 to the 0, because the rule is to keep the base the same and subtract the exponents. Right? That's what we talked about. Max said, listen, the answer should be 1, because anything divided by itself is 1, except 0, right? We talked about 0. Cookie Monster, come on. Okay, so who is correct? Amy or Max? What are you feeling? And now maybe turn and talk to your neighbor and decide. Excuse me. So who can be correct? And we just take answers. Anyone think Amy's correct? Well, Amy followed the rule, right? If we have x squared equals divided by x squared, the rule is to keep it and subtract the exponent, so we get x to the 0. That's what we did. So Amy's right? Keep the base the same minus the exponents to the 0. So Amy is right. And people are like, whoa, 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 Mr. Moran. That can't be right. Because 2 squared over 2 squared is the same thing as 4 over 4. And that's 1. And I'd be like, yeah, that seems to be true. Right? And I would say, who thinks Max right? Everyone's like, whoa, Max is right. Okay. And then I say, what if I said both are correct? That both Amy and Max are both right. I knew it. I thought it. I knew it. Or maybe you're still confused. But if Amy's right and Max is right, well, if they're both right, then that implies that 2 to the 0 is the same as 1. That 2 to the 0 must be 1, right? I don't know. Okay. So if they're both right and they're both following rules, then that must mean 2 to the 0 is 1. Okay. You know what? Let's look a little deeper here. That can't be the right? Okay. So I have this table here. It seems to be that 2 to the 0 is 1. But I think looking at some patterns might be helpful, because I kind of still don't believe it, right? I still don't believe that 2 to the 0 is 1. So I have another pattern. We know that 2 to the 4th is 16. 2 to the 3rd is 2 times 2 times 2 times 2, 2 times 2 times 2, 8. 2 squared, 2 times 2, 4. 2 to the 1st, 2. So, forget we even had the exponent part. When you were younger, if you were given the pattern 16, 8, 4, 2, what would be the next number that makes sense? 16, 4, 16, 8, 4, 2. What would be the next number that has to be? Well, what happens from 16 to 8? 8 to 4, 4 to 2. What's happening each time? What's halving, right? Half of 16 is 8. Half of 8 is 4. Half of 4 is 2. So half of 2, right? It's dividing by 2 each time. Has to be 1. Or going up, it's times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So this has to be 1. So, whoa. Yep, more evidence right here that 2 to the 0 equals 1. I wonder if that holds up throughout, right? Like, is it just 2 to the 0? Okay. 3 squared is 9. 3 to the first is 3. Going up, what's happening? How do you go from 3 to a 9, or 9 to a 27, 27 to an 81? Well, that's times 3. 3 times 3 is 9. 9 times 3, 27. Going down, it's divided by 3. Or even just to keep that pattern, this would have to be 1. 1 times 3, 3. 3 times 9, 3 times 3, 9. 9 times 3, 27. Yeah, so 3 to the 0 is 1 as well. What? How about powers of 5, right? 5 squared, 25. 5 to the first, 5. We add another 5, so it's like times 5. So what does this have to be? 5 to the 0 has to be 1. 1 times 5, 5. 5 times 5, 25. Or even going down, it's dividing by 5 each time. Has to be 1. And guess what? Even with powers of 10. 10 squared is 100. 10 to the first, 10. What's 10 to the 0? It has to be 1. You're being like early mathematicians. It has to be 1. Because it has to work with what we already established. Right? If we go down, we're dividing by 10 each time. Going up times 10 each time. So, the thing we weren't sure about, right? If 2 to the 0 is 1, and 3 to the 0 is 1, and 5 to the 0 power is 1, and 10 to the 0 equals 1, then what is 4 to the 0? Yep, it is 1. So, there is a rule that we just explored and we proved. The rule is any base to the 0 power equals 1. Except, well, it brings a question about 0 to the 0 power. But any base to 0 power other than 1, any 0 power, any base to the 0 power other than 0 equals 1. So a to the 0 power is 1. Great. Okay. Lot to listen to, lot to think about. We're going to jump into negative exponents now. So, I wonder if that was a homework problem. That might make more sense to be a homework problem. Anyways, okay. We got to talk about negative exponents. Just a quick review of positive exponents, right? So 2 to the 4th, that's exponent form. In extended form, it's 2 times 2 times 2 times 2. And in standard form, or the simplified form, we get 16. That makes sense. 4 copies of 2. Because we have negative numbers, it's okay to have negative exponents. So now we have to think about the idea of a negative exponent. If 2 to the 4th equals 2 times 2 times 2, which equals 16, what could 2 to the negative 4th power be? And here we throw out ideas. Think about what could 2 to the 4th is that. What could 2 to the negative 4th be? Some students throw out negative 16. And I'm like, that's awesome, but it's not right. Some students throw out negative 8, but that's not it either. Some students throw out that it's 16. And I say, awesome, but that's not right either. So, we're kind of stuck trying to figure out what is 2 to the negative 4th. I could just tell you, but you know what? You know me. I just want you to discover it on your own. Sure, I have this little handout here. I want you to complete the table using what you know about positive exponents to see if you can find the standard and expanded form of negative exponents. And you're going to do what mathematicians did a long time ago. They had to base negative numbers and exponents on what they knew before. So I'll help you. 2 to the 3rd is 8. And an expanded form is 2 times 2 times 2. So we're going to add that. 2 squared is 4 because it's 2 times 2. 2 to the 1st, 2 and 2. 2 to the 0, well, we talked about it a second ago. What's ending in 0 power? It's 1, right? Expanded form, we'll kind of talk about it. We haven't figured out what expanded form of 2 to the 0 is. But what I'd like you to do is we're going to answer the rest of this. So you have this handout, right? I want you to don't worry about the expanded form. Don't even worry about the exponent form. Let's just think if we were continuing the pattern, what might we end up with, right? 8, 4, 2, 1 times 2 times 2 times 2. What happens as we're moving down? Like, what would the next number be if we're going down the sequence? 8, 4, 2, 1. Well, it's a half, right? Because 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. Right? Or halving. So what's half of a half? People say a fourth. I'm like, awesome. What if we split a fourth in half? Well, we're left with an eighth. And what about half of an eighth? 1/16, right? Okay, and when I take my hand away, it seems like we've figured out the answers, at least the standard form of this. Very simple. Just early beginning. What kind of answers does it seem we get? What's the standard form of negative exponents? What do we seem to get? And people say fractions. Yeah. It's weird, but it works. So negative exponents have something to do with fractions. The key to really understanding it is understanding the expanded form. So I'm about to have you try to explore that. So with your neighbor, you're going to go on to number 2, A, B, C, and D. And think about what the expanded form is of these negative exponents. So go ahead, pause, read the worksheet, give it a try. We'll come back and talk about it. Oh, hold on. Might have just lost you now. All right. So we should have an answer. We come back, we talk about it. It says to help us understand what 2 to the negative 4 equals, let's use what we've been learning the last couple of days in math. Use the power rule of 2 to the 4th over 2 to the 8th. 2 to the 4th divided by 2 to the 8th to simplify. So the rule is keep the base the same, subtract the exponents. 2 to the 4th minus 8 is 2 to the negative 4th. Okay. And we did that last couple lessons. Okay. B says to write this out in expanded form and to simplify using canceling. So 2 to the 4th over 2 to the 8th equals 2 times 2 times 2 times 2. 2 to the 8th is 2 times 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 2. And you would have remembered that for simplifying is that you get 1, you get 1, get 1, you get 1. So 1 times 1 times 1 times 1 is 1. 1 times 2 times 2 times 2 times 2 is 2. 2 times 2 times 2. So 2 to the 4th over 2 to the 8th is 1 over 2 times 2 times 2 times 2. Using what you did in part A and B, what is the expanded form of 2 to the negative 4th? Well, I hoped and what you gathered is that these are the same, so these are the same. So 2 to the negative 4th is 1 over 2 times 2 times 2 times 2. And now we know, we can fill it in up here, but we'll do it here. What is the standard form of 2 to the negative 4th? So 2 to the negative 4th, we discovered is the same as 1 over 2 times 2 times 2 times 2, which if we're going to write it in another form is 1 over 2 to the 4th, which is 1 over 16. Boom. And so that adds to our understanding. So I think we read it. Let's see. Okay. It's a lot of processing. I'm going to go back and fill the table. So 2 to the negative 4th is 1 over 2 times 2 times 2 times 2. 4 copies of 2 in the denominator. So what about 1/8? Well, that would 2 to the negative 4th, 2 to the negative 3rd, is 1 over 2 times 2 times 2. 2 to the negative 2nd, to get 1/4 is 1 over 2 times 2. 2 to the negative half is 1 over 2. And the expanded form of 2 to the 0 is 2 divided by 2. Okay. Now that's just the understanding part, where it comes from, what we discovered. Now there is just a rule. We just proved that 2 to the negative 4th was 1 over 16th, which is the same as 1 over 2 times 2 times 2, 2, equals 1 over 2 to the 4th. So the general rule is if you have a base of a to an exponent of negative b, we can rewrite that as 1 over a to the b power. Cool. So we're going to have to turn 5 to the negative third into a form where we can find its standard form. So 5 to the negative third is equal to 1 over the base of 5 to the positive 3 exponent, which is 1 over, in expanded form, 1 over 5 times 5 times 5, which is 1 over 100, 1 over 125. Do I have to bring it all the way there, Mr. Moran? Yeah, you do, kind of. How do we write this? We have our base, we have our exponent, so it's 1 over our base to the positive exponent, which is 1 over negative 2 times negative 2 times negative 2 times negative 2, which is 1 over 16. Do we have time for that one? Is that where we're at? It's been a lot of notes. Well, I guess maybe we skip it, but no. It's worth talking about. We're on recording, so you can pause or rewatch me. Negative 2 to the negative fourth is really negative 2 to the negative fourth. Because negative 2 is really negative 1 times 2 to the negative fourth. Super annoying. So it's negative 1 times 1 over 2 to the fourth, which is negative 1 times 1 over 2 times 2 times 2 times 2, which is negative 1 times 1 over 16, which is negative 1 over negative 1 divided by 16. All right, this is a longer video, but you know what? I've now decided I'm going to make the first part homework. You could watch it and understand it, so this part won't feel as long. So the opposite general rule is if you have 1 over a base to a positive exponent, we can write it as the base of the positive exponent in the denominator to the negative power. Okay, so if we have 1 over 8 of the b power, we can write that as take our base a and make it a negative exponent. So we're going to express this using negative exponents. If we have 1 over y to the positive 2, that's the same as a y base to the negative 2 exponent. And if we have 1 over 1 divided by 10 to the second, keep our base in the denominator, which is 10, into the negative 2. So it's kind of reversing it. It's like if I gave you that, it's that. But if I gave you that, it's that. So it's like a mix back and forth. So classwork 1 today is kind of reversing. You're going to write the top ones as positive exponents and the bottom in their negative exponent form. I'm going to post the answers because this is a video. Right? Let's see. Is there another one? Okay. And there's a classwork 2. But go ahead and do it. We're going to write each as a positive version of its exponent and one as a negative exponent. Pause me if you want to work through it. I'm going to write the answers. All right, there are the answers to those. I guess I could always post answers to this. This video is kind of long anyway, so you get a good practice. Anyways, there's the answers, and I'll see you next lesson.